Here they have mixed parts A and part B of the epoxy together, and it's going to start reacting and heating up. And so before it gets too hot, we pour it inside this fabric liner. There's plastic on the outside to prevent the resin from coming out from the inside. The fabric on the inside is very porous, and they use a heavy roller to force the resin into the fabric. And the liner is then pulled into this air cannon, and it rolls up on the inside of this reel. There's a spool on the inside. And once it's completely rolled up on the inside, over here, there's going to be a thin nozzle that gets attached, and the lining will go through the nozzle, and it'll actually turn inside out as you increase air pressure inside the tank. So right now, the fabric with the resin is on the outside, and the plastic is on the inside. So if you turn the balloon inside out and blow it a certain way, you can turn it inside out. That's called air inversion. And so right now, that whole spool is unwinding, and the lining is turning inside out inside the pipe. And these holes show that the resin will come out of these holes, because the resin is no longer on the inside of the pipe, of the lining, because it's turned inside out. The fabric and the resin are on the outside. Here you can see the fabric coming towards you, and it's inverting, and you can see there's some extra resin in the bottom of the pipe. And when this lining is completely gone through the entire pipe, the end of the lining will open up and all the air will escape. And at that point, you cut open the lining near the entrance points of the pipe, and you load a balloon, a special balloon called a calibration tube inside the air cannon. And then you shoot the calibration tube inside the lining, and you inflate that balloon for the required 3 to 4 hours. At the end of the 3 to 4 hours, you pull the balloon out. That's what these guys are doing right now. They pull the balloon out, and only the hardened pipe lining is now in place. So this is the oldest technique. This is what you can see, the nozzle in this picture. You can see where the nozzle is, that the lining originally gets attached to. It goes through the inside of the nozzle, and you do the same with the balloon. Okay, so when they first shot the lining in, they put this nozzle on, they put the lining through the middle of the small piece of the nozzle, and then they wrap the lining around the outside of the nozzle. That way, when you increase air pressure on the inside, the lining turns inside out. They've done the same with the balloon here. They rolled the balloon into the air tank. They took the end of the balloon and they put it through the middle of the nozzle, and they turned it and wrapped around the outside of the nozzle. Then they increased air pressure, and they're letting the balloon turn inside out inside the lining that had turned inside out before. And then you let that balloon cure in there, stay in there for about 4 hours. And after that, you pull the balloon out, and you get a perfectly hardened pipe lining on the inside of your cast iron or whatever the case is. The downside of this technology is that it covers up all incoming pipe connections, just like these holes got covered up. And so you have to find a way to cut those holes open, and it becomes a big headache. You got to go get up on a roof stack, or you got to take off toilets. You got to buy special technology. It takes a long time. If you don't do it right, little edges of lining will catch on debris and cause repeated backups. And this is what the lining looks like at the end. You can see it's completely continuous. So if there are any branches that came into this pipe, they got covered up. This is the oldest technology. We prefer to avoid it.